Okay, so I know it's a snow day. We'll do the best we can, or maybe it's not a snow day. I'm making the notes before I know for sure. But anyway, I'm going to go through the notes and tell you what the process is in order to figure out empirical and molecular formulas. So the first thing you need to know is that the material that we're covering here is from section 6.3, and you are required to do 6.3 homeworks, questions 1 through 6, on page 208, and that's going to be due Monday. Don't forget that you're going to have, or Tuesday if you're e-block. Don't forget that you're going to have a requiz on moles the first class next week. Now, before you watch these notes, you should really have your empirical formula note-taking sheet out. For those of you who are in school, I handed them out. Those of you who are at home, if you go to Unit 4 and you look for week 16 and the notes today, you will see right next to that is a worksheet that is basically a note-taking sheet that you're supposed to use in conjunction with this. Now, this is your sixth warm-up. So what you want to do is probably pause your video for a moment to have a chance to write everything down. So this is the last warm-up of the unit. But basically the idea is we're going to try to figure out the relationship between formulas of compounds and the mole, which is pretty much everything that we're doing. Now, I don't expect you to know the definition of empirical formula, but essentially what empirical formula means is the lowest whole number ratio of subscripts in a compound. Now, whenever we write a formula for an ionic compound, it is always written as an empirical formula. Remember, ionic compounds have a cation and an anion, right? Molecular compounds are made completely of nonmetals. There's no ions involved. Normally, the formula of a molecule shows all of the atoms present in the entire molecule. Once in a while, you can factor something out to generate what's called an empirical formula, but that is not the same thing as the molecular formula, and we'll learn about that as we go through. Now, why do we need to figure out chemical formulas? Let's say, for instance, you own a drug company, and your drug company wants to find a new antibiotic. So one of the ways that this was done, I know this may sound crazy, is they would collect soil samples from rainforests in the Congo, rainforests, in Thailand, rainforests in Brazil, and they would bring them back to the company's site where they're going to test them. Each sample would then be extracted with water. That means mixed with water, filtered, so they have whatever was water soluble in the formula. And then they would check and see if any of those samples, for instance, would kill bacteria. Now, if they found a sample that killed bacteria, we got to use some chemistry to get to the point where we can figure out the formula of the compound that's somewhere in that soil extract. Now, one of the most basic ways of doing that is to find out the percent by mass of each element present in a compound. And if we do that, we have machines that can do that, then we can use that information to find the empirical formula, the lowest whole number ratio of the elements to each other in the compound. That is the first step to determining the molecular formula of a compound. Why do we need the molecular formula? Well, if we have the molecular formula, we're able to then potentially manufacture that compound, which could be worth billions of dollars to a company. So it's very important for them to be able to start with something unknown and figure out what it is made of and how the atoms are attached to each other, since it's basically worth so much money. Now, there are an organized series of steps to define the empirical formula of a compound. And this is where having your note-taking sheet would actually be pretty handy. Now, I think there is an inset. Your note-taking sheet looks like this. Hopefully you can see that. At the top, it technically says Notes and Practice for Empirical and Molecular Formulas. Now, have that sheet printed in handy because we're going to fill out parts of it as we go through. Now, once we know the percent composition of a compound, we can predict its empirical formula. How do we do that? We work backwards from the percent composition which basically is we're going to use that to find the mole ratios, which are the subscripts of our empirical formula. Now, here is the first example. What is the empirical formula of a compound that is 85.6% carbon and 14.4% hydrogen? Now, if you take a look at your note-taking sheet, you will notice that it starts out with a box that says 85.6% carbon and 14.4% hydrogen. So that's where we're at. The very first thing you have to do is convert percentages to grams. Now, this seems really silly. Basically, it means multiplying 100 grams over 100%. So really what you're doing is you're just literally dropping the percent symbol and adding the grams symbol. If you've got the percentages already, it makes sense. Now I want you to think about that. Suppose you have 100 grams of a compound. Doesn't 85.6 and 14.40 add up to 100? If you had 14.4 grams of hydrogen over 100 grams of compound, wouldn't it be 14.4% hydrogen? Yes, it would. Now, the very first box you fill in, you should put in 85.6 grams of carbon and 14.46 grams of hydrogen. So the first step is just to basically get rid of the percent symbol and add a gram symbol when starting with percentages. The second thing we have to do is figure out how many moles these number of grams represent for each element. Now think about it. This is a gram to mole conversion. So what you're going to do is you're going to take, remember, gram to mole, every element, 1 mole of it equals the average atomic mass in grams. So what you do is you're going to take your grams of carbon, divide it by the molar mass of carbon. Well, really, it's the average atomic mass of carbon. And you're going to take your grams of hydrogen and divide it by the average atomic mass of hydrogen. So this is basically the second step, step 2, where it says convert moles to moles using the average atomic mass. So fill in 7.127 moles where it says carbon on your sheet and 14.29 moles where it says moles hydrogen on your sheet. Now, we're still not there yet. We have more work to do, all right? Because this is not going to be the right ratio yet. The third step is to find the lowest whole number ratio of the different amounts of moles to each other. What we're trying to get to is whole numbers. So the way you do that is you divide by whichever value. You've got two values here, 7.127 and 14.29. Divide by whichever one is smaller. Divide both of them by that. And you will see what happens. If we divide 7.127 by 7.127, it equals 1. If we divide 14.29 by 7.127, it equals 2. And you will notice that for every 1 mole of carbon in the formula, there are 2 moles of hydrogen in the formula. So the empirical formula, the lowest whole number ratio for this particular compound is CH2. And so your empirical formula, you'd fill in that blank, you'd write CH2. And step 3, you can see what you were supposed to do. You're just supposed to do the division step. Now, what happens if we don't get a nice whole number like 1 here and a 2 there? There is a fourth step, and I'll show you what that is next. You always do the first 3. Sometimes you have to do the fourth. So here's another problem. All right, if things are slightly harder, this is another example, it's slightly harder. It's going to add the fourth step. Okay, so again, we're just starting with a simple compound, and we have the percent of carbon and the percent of hydrogen. So on your note-taking sheet, you go down, you'll find those values, and guess what the first step is? It's to get rid of the percentages and call them grams. So you convert to grams. So in your first box, write 81.68 grams carbon and 18.32 grams hydrogen. This is in part 2. Now, let's look at the second step, all right? Again, the first 3 steps are always the same. This example is going to add a fourth step. Determine how many moles the grams of each element represents. to go from grams to moles, just like we've been doing all along. Since these are elements, we have to divide by the average atomic mass. So for carbon, we come up with 6.801 moles of carbon. For hydrogen, you'll notice I didn't use 1.008. I apologize for that. This was an older periodic table, but it's close enough it's not going to make any difference. I have 18.14 moles of hydrogen. So if you're going to step 2 on your list, right, this is second section, you're going to, where it says moles of hydrogen and moles of carbon, you're going to fill in those values. Now, the third step is still the same. Divide each value by whichever one has the least number of moles. So we're going to divide both by 6.801. If we divide both by 6.801, you will notice that we do not end up with whole numbers this time. 6.801 divided by 6.801 is 1. That makes sense. But 18.14 divided by 6.801 is 2 2/3. Now, we cannot have subscripts of compounds with decimals. So what do? We have to do a fourth step. Now, if step 3, we don't get integers, we have to do something else. What we have to do is look at the values, and we're going to have to multiply all of the subscripts, not just the one that's not a whole number, but we have to multiply all of them by the same factor, okay? So here's a list of some of the factors. If the decimal was 0.333 or 0.667, we multiply by 3. For decimals that are 0.5, we multiply by 2. And for decimals are 0.25 by 4 or 0.2 by 5. These are the only kinds of decimals I will give you. Now, I want you to pay attention here. The homework, section 6.3. If you look at question number 6, okay, you are not going to get one of these nice multiples. You're going to have to multiply all of the subscripts by the number 11. Please make a note of that, okay? So, since we did not have in this example question whole numbers, one of them was 1, the other one was 2.667, we have to multiply the subscripts by 3. So, this is our fourth step. We take our values from step 3 and we want to get them to whole numbers. So right now the ratio is 1 carbon to 2.667 hydrogens. That's not a whole number. If we multiply both by 3, we will get C3H8. Excuse me. C3H8, by the way, happens to be an alkane. It happens to be propane. Now, take a look. That is the lowest whole number ratio. That you can't factor out a common factor. C3H8 is the empirical formula. Okay, now, molecular formulas. Molecular formulas are not necessarily the same thing as an empirical formula. Once you have an empirical formula of a compound in grams, how can you find the molecular formula? So let me show you what I mean by that. You've got to have more information. For instance, this is actually one of the homework questions. I think it's number 3 in your homework. The piece of information you need to know is you have to know the molar mass of the whole compound. Now, if you don't have the molar mass, you might have other information that allows you to calculate the molar mass. But unless you can figure out the molar mass, you're not going to be able to go from an empirical formula to a molecular formula. Now, in order to do this, this is the hardest part of this. How do we figure out what we need to do is you have to realize that the empirical formula has a value factored out. Maybe we factored out a 2. Maybe we factored out a 3 or whatever in order to find that empirical formula. So the way we figure it out is this. We use this extra piece of information, which is the molecular formula mass, which is the same thing as the molar mass. And we divide it by the empirical formula mass. So what we're looking for is a ratio. The molecular formula mass divided by the empirical formula mass. If we multiply the subscripts of the empirical formula by that multiple, you will have the molecular formula. Now, let me see if I can give you an example. If you go to the challenge problems at the end of the worksheet, there's 2 of them. Challenge problem number 1 is just a standard old empirical formula problem. Problem number 2 on the back of the worksheet that you use, the note-taking sheet, you will see that you're asked to find the molecular formula. So once you have the empirical formula from number 1, step 1 for this is to find its mass. Step 2 is we need to know the molecular mass or molar mass of the whole compound. In question number 2, we're told enough information to determine that. Remember, molar mass has the unit grams per mole. We're given the grams of something and we're given of the compound and we're given the total number of moles that represent that mass. So all we have to do is take the grams and divide them by the number of moles and we'll have the molar mass. Once we have the molar mass of the whole compound, we divide it by the empirical formula mass. And then all we have to do is determine the subscript. Please look through the notes. Don't worry, we'll go back through this. You'll also have a whole worksheet next week on this to be able to figure out how to do this properly. All right? Now, what you need to do is nothing more at this point. Just make sure that you have this other sheet filled out as best you can. Try to do the 2 challenge problems and then bring them in and I will check them over in class on Monday. Thanks. Bye.